DJI FlightHub 2 now supports area route planning for both ortho and oblique missions, and cloud mapping for 2D or 3D model. Let's have a look. Area route. Enter Flight Route Library. Click the plus icon to create a new route. Then select the aircraft and the payload. Choose Area Route and enter the route editing page. Click to set the takeoff point and create the survey area. Click the check mark and the FlightHub 2 will generate the route automatically. Alternatively, you can right-click to convert the pre-marked area into survey area. Both types of area can be edited. Collection mode. If you need to obtain a 2D model, please select Ortho Collection. Choose Oblique Collection for 3D model. After that, flight routes will be created. By adjusting GSD, the flight altitude will be changed. Smart Oblique. When using Smart Oblique, the aircraft will adjust the payload for multi-angle shooting. It can reduce the number of flight routes and improve the work efficiency. When disabled, Oblique Collection mode will be switched to 5 flight routes. Safe takeoff altitude. The safe takeoff altitude should be higher than any obstacles between the takeoff point and the first waypoint. If it is lower than the first waypoint, the aircraft will climb up to the altitude of the first waypoint before flying towards it. If it is higher than the first waypoint, it will reach the safe takeoff altitude first, then maintaining the height while flying directly above the first waypoint, then descend. Altitude mode. Altitude mode now supports ASL, ALT, and AGL. AGL is for terrain follow. When changed, the value of altitude will be adjusted while keeping the same flight route and GSD. After changing the altitude, the GSD will be synchronized. Real-time follow. When real-time follow is enabled, the color of flight route will be purple. Terrain follow file management. When real-time follow is disabled, you can manage the terrain files. In AGL mode, the displayed model on the map that includes the survey area will be used as the ground data. Priority is given as follows: 3D models, 2.5D models, and global elevation data. Among 3D models, they have no difference, and the highest point will be selected as the reference point. 2.5D models will only display after it has been enabled on the map. The gimbal tilt angle is only available in oblique collection mode, which can be set from 10 to 45 degrees. It is recommended to lower this value in areas with dense buildings in order to capture the images between. After making changes, the flight route will be regenerated. The smaller the value, the smaller the flight area. It can be also adjusted based on the flight safety. Global flight speed. You can set the flight speed of the aircraft during the mission. Using the default speed is recommended to improve efficiency. Course angle. The course angle can be used to adjust the route direction. Using the default angle is recommended. Elevation optimization. Elevation optimization is available when using ortho collection. When turned on, the aircraft will fly towards the center after the mission is finished and capture a set of photos. This will result in a more accurate altitude information. It is recommended to enable for mapping users. Upon completion. Upon completion means the default action after completing the mission. Return to home is recommended. Advanced settings. Side and frontal overlap ratios refer to the density of photography during the mission. A higher overlap ratio results in more photos taken over the same distance, which can improve the model accuracy but slowing down the flight speed. Using the default values, is recommended for a balance between model accuracy and mapping efficiency. Margin refers to the distance by which the survey area is extended outward. Increasing this value can improve the model quality at the edge when doing oblique collection. Photo mode refers to the photo taking method during the mission and can be set to time intervals or distance intervals. Aerial survey users are suggested to choose distance interval shot. Custom camera angle. Custom camera angle is only available when using ortho collection. It is commonly used for solar panel inspection. Adjusting the route start point allows for manual selection of the first waypoint. The flight route will be regenerated upon change. Once settings are complete, save the mission. You can view or re-edit the flight route in the flight route library, which you can also rename, copy, and download the mission. If you are using DJI Dock, go to Task Plan Library, click Create Plan, and select the route and device. Based on your needs, you can choose to execute on a scheduled time or right away. After the mission is completed, DJI Dock will upload the photos to the DJI FlightHub 2. Cloud mapping. You can start cloud mapping from the model library or media files. Fill in the model name. Click Select Photo and choose the corresponding folder by flight routes or media folders. Click Recenter to view the location of the photos, or you can remove the selected folders. After confirming the photos, select 2D mapping or 3D mapping according to your needs. Click OK and wait for the mapping. If you choose 3D mapping, it is recommended to set a value of 0.2 for model simplification to improve the mapping efficiency and browsing experience. If you have a high-spec computer or requires a more detailed model, you can increase this value appropriately and enable HD model to view with higher precision. For more information on how to use DJI FlightHub 2, you can click on the FAQs or read the user manuals. Thanks for watching.